Hello friends, and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which finds the number of half nodes in a binary tree. First, let us make it clear what exactly half node in a tree means. A half node is one which has only one child. Let us consider this tree for example. In this tree, nodes 7, 5 and 9 are half nodes as each of them has only one child. Hence, the count of half nodes here is 3. Now let's see the algorithm which will assist in finding the number of such nodes. Note that we are using a queue data structure. Also, we need a count variable to store the number of half nodes. We initialize count to 0. Let us also have a sample tree to test our algorithm. We begin with step 1 and push the root node, which in our case is 2, into the queue. Since the queue is not empty, we enter the while loop. As we enter the loop, we dequeue the node already there in the queue and assign it to temp. Here 2 will be dequeued and hence temp will point to 2. Now we will check whether temp is a half node or not. If it is so, we will increment count. So half node is one which has only one child, which could either be a left child or be a right child. In our tree, nodes 7 and 9 have a right child and node 9 has a left child. We will use the code given in the right for this. Let us see the first if in the while loop. Right now, temp is pointing to 2. If not temp left means that if temp left is null and temp right is not null, or if temp left is not null and temp right is null. Since neither condition is satisfied, value of counter remains same. Now we will push the left child of the temp node if it exists, followed by the right child. So 7 and 5 will be enqueued into the queue. Since queue is not null, we loop. Again, we dequeue the node in queue and assign it to temp. Here 7 will be dequeued, so temp will now be 7. Again we check the first if condition. Here 7's left child does not exist and its right child, which is 6, exists. So 7 is a half node and hence count is incremented by 1. So now count becomes 1. Again we push the children of temp in the queue. So 6 is enqueued. Since queue is not null, we loop. Now 5 will be dequeued and assigned to temp. Again we check if 5 is a half node or not. Since 5 has only a right child, it is a half node. So the value of counter is again incremented by 1. Then the child of 5 is pushed into the queue. Again, since queue is not null, so we enter the loop and 6 will be dequeued. 6 is not a half node, so the value of counter remains same. Then the children of 6, that is 1 and 11, are enqueued. Then 9 is dequeued and assigned to temp. Since 9 has a left child only, it is a half node. So the value of counter is now incremented to 3. Then 4 is enqueued in the queue. As you can see, 1, 4 and 11 don't have any children. So they will be dequeued one by one from the queue till the queue is empty. First 1 is dequeued. Now 11 will be dequeued followed by 4. Now the queue becomes empty and control will come out of the loop. So the final value of count that will be returned is 3. Let's have a look at the time complexity of the program. This code will run in big O of n complexity. Here n are the number of nodes in our tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.